Hello everyone, welcome to pipebench.com. Today, I would like to introduce you a great online calculation tool we developed based on API RP1102. Published by American Petroleum Institute, API 1102 is widely used by many pipeline engineers in the world for their highway and railway crossing design. The procedure and the criteria establishing this practice has proven to be very reliable to guide your pipeline road crossing and railway crossing design. The only drawback of this practice is that you have to go through a lot of graphs and parameters during your calculations. This can be very challenging, especially for those new users. We believe this online calculation tool can greatly simplify your design process. Now let's take a look at an example to show you why. First of all, let's put in some pipe and soil parameters. The first section, you may see there's a two drop down for you to select the pipe size and the wall thickness. These are very typical values that you can change based on your design to make it easier. You can also double check the outer diameter and the wall thickness on the statement below. But in this case, let's say we are using a 12-inch but a 1/4-inch wall thickness. You may find out that the 1/4-inch wall thickness is none of the schedule or wall thickness shown here. So in that case, we need to go back to the pipe size, select custom, and then you can manually put the wall thickness that is not so common. So in this case, the default value is a 1/4 inch. So let's keep it that way. And then for pipe grade, let's select 42, X42. As you can see, the SMICE value is already showing below. And the type of steel pipe, basically in API 11.2, we can select seamless and ERW or SAW. So in this case, let's say it's 12-inch, it's more common to have ERW pipe. Design pressure, let's keep it to be 1000 psi. The next two inputs are temperatures. So for installation temperatures, the temperature actually assumed to be that day when we do the construction. Usually we can assume a reasonable number based on the season. Let's say in this case, let's assume 60 Fahrenheit is the temperature we actually see during the construction. And the maximum minimal design temperature will determine the maximum delta T for this design. It will also determine temperature derating factor as well as the thermal stress during the stress calculations. So in this case, let's say the maximum temperature is 110 Fahrenheit. Depth of cover means the distance from the road surface to the top of the pipe. It has to be more than the minimal depth of cover required for your project. So in this case, we can say it's a relatively shallower cover, let's say 4 foot. And the bore diameter depends on what construction method you use. Let's say if we're using open cut, then this bore diameter can be the outer diameter of the pipe itself. If you're using the trenchless crossing method, such as boring, here we typically use the pipe outer diameter plus 2 inch. So in this case, we can assume we're using boring technique. So here let's put 12.75 plus 2, rounded up to 14.8. So it's all good. The soil parameter, soil unit weight, if you have geotech data, it has this exact number. You can put that in if you don't know. Typically, we put a 120 pound per cubic feet. This is a very typical value. So let's Assuming we don't know, let's just use the typical value here. So when we go into this side, there are some additional soil parameters we need for the design. The first one is soil type. So we have put in 4 typical categories, including the API 11.2 appendix. So this is 4 typical soil categories for your design that you can choose from. And also there's 2 parameters below, modulus of soil reaction and modulus of soil. Those values are typical default values, basically based on the API, based on the API 11.2. So you can change the soil type. So this default value will change by itself. So in this case, let's say we assume the soil type is loose sand. Then should choose the loose sand and gravel selection. But you don't want to use the default value. Let's say you have a geotech data or geotechnical engineer told you to use a different number. Let's say the resilient modulus of a soil, you want to use 10 KSI. You can just click on the drop down and manually select 10. So the whole setup here is to make sure you have enough flexibility for your design. And at the same time, if you're not sure what value you use, you still have a default values to select. Okay, let's going down. The next input is for us to select pavement type. So there are 3 options based on API 11.2. Flexible pavement, no pavement, or rigid pavement. Rigid pavement is probably more typical for highway design. If you have a gravel road, normally you can select a flexible pavement, and it's a dirt road or it's not even a road, you can select a no pavement. So in this case, let's say we're crossing a highway, we're gonna select rigid pavement. And design Excel configuration is based on what you assume for the vehicle to travel on the road. For highway crossing, normally we use tandem Excel to account for those big semi trucks. Design factor, that depends on which country you are with, what projects you use. You assumes in the States we typically assume 0.72. This is based on the 49 Code of Federal Regulations, Part of 192 for gas and Part of 195 for oil pipelines. And apply design surface pressure. You can manually change it, but since we select the tandem Excel, so we're gonna just put a 69.4. This is a typical value. Of course, you can use a different value based on API 11.2 Annex A. But in this case, we want to use typical ones, which is 69.4 PSI. This is the design wheel pressure. In the next sections, you can see everything's in gray, so you can't really change it directly. But we did give you guys options to manually override this typical value. For example, here, this is the total effective stress limit in percentage of SMICE. So for API 11.2 used in the States, actually, this is the same as the design factor, which in terms of percentage of SMICE will be 72%. So that's a default value. Impact the factors depends on the many other scenarios. You can manually change everything by click in the front. Like say sometimes you do a project in other countries, you don't need to follow the 72% effective stress limit. You can say 90% is still acceptable. You can override the limit here. But in this case, let's keep the default. at 72%. Same thing for impact factor, and click, and then you can change it to a less conservative number, or based on the depth of cover. But in this case, we use 1.5 highways. That's typically how we do it. Longitudinal joint factor is based on the pipe type. Since we're selecting ERW, that should be 1. Temperature derating factor should be 1 as well. So with all the parameters in place, now basically we can check the calculation results directly. One best thing about this online calculation tool is it automatically helps you to select all these factors. We can see if anyone use it before using your spreadsheet or using hand calculation, it can be very challenging to go through all the graphs in this practice to select all these numbers. But here is very easy. Everything is automatically selected based on your inputs. You can click on it to check it. Basically, is a good summary about what you select and how it is selected. All these graphs are based on exactly the same graphs in API 11.2. As you can see, you can double check everything manually. So I'm just go through it one by one, so you can see everything is done by itself based on the inputs you put in earlier. So is the road pavement factor, road axle configuration factor, that based on the pavement type, and also the tandem axle configuration we selected earlier. And the fatigue endurance limit of girth yield, and also the limit of a longitudinal weld is based on the pipe grade and the type we selected. So in this case, this is the value we have for the ERW pipe. Scroll down, we have the results section. The results section basically is a summary about all kinds of stresses we calculated based on our inputs, and the stress check is to compare the calculated stress to the stress limit specified by API 11.2. If you show all pass, it means your design is good, is acceptable for 11.2. If there's any parameter shows failed, then you have to go back to change your design parameters to make sure everything pass. Here you can see we have a note here saying some projects may set total effective stress at 90%. That's what we're talking about. In order to change the stress limit here, we can go back here and change it manually by click here and say we change to 90%. And here we can see the stress limit increase to 90% of the SMICE. And the last, when everything is done, we can generate a PDF report like all of our other tools on our website. By simply click on the reports, we can say project name is a test. Put in the day like today. Revision A, review, and say John. John is developer, approver is Joe, and reviewer is Mike. And let's open it. So a PDF version of this report will be generated with all your input data, API level 2 parameters selected by themselves, and results and stress check. So you can save this file as your calculation evidence and a file to your projects. One more thing we would like to point it out is for those users in other countries that do not use imperial units, use metric units, we have a simple way to help you to do a design using metric systems. All you need to do is go to the top of this tool and you select metric. So basically all the inputs and the parameters will convert to metric units by itself. You can change and you can do anything using the units that are suitable for your country, location, and projects. Is a really convenient tool for everyone to use. For some of the parameters, we kind of already shown both. Like I say, this one for the limits, we have a 12,000 psi and also 83 MPa. But all other major inputs outputs is already being converted by itself. So when you click on the report, it will show whatever the unit system you selected. So we have another tool dedicated for the railway crossing design, also based on API 11.2. Everything is largely the same as the highway crossing design tool. I just want quickly pointed out some of the key difference for this one. So let's say, for example, we have almost the same input section and the only thing difference here is pretty much the track type instead of the pavement type. So you can select a single track or double track. So in this case, let's say there's a double track railway we're going to cross. Design factor, again, is a 0.72 for in the States, but some country actually use a lower design factor. Let's say we change this to 0.5 as the design factors. Apply design surface pressure, same thing. 13.9 is the typical. We're using API 11.2 based on Cooper E80 loading. You can change it to greater number, but most of the cases we just use the typical recommended surface pressure. So let's keep it at 13.9, and everything else we keep a default value. Same thing, we'll generate all these graphs by itself. We everyone, you can double check everything based on your understanding. The fatigue limit is pretty much the same as a highway. The results and criteria is pretty much the same. And now we compare the stress limit. We can see everything passed, but we have one fail criteria here for the girth weld fatigue. So basically our girth weld, our longitudinal stress over the limit. So we have to do something to make sure this pass. Usually, if the girth weld fatigue limit is over, usually the most effective way is to change the wall thickness. So here we're using standard wall thickness for 12-inch. So let's say we are using schedule like X, have heavier wall in this case. So instead of 0.375 inches wall thickness, let's use 0.5 inch. And then let's going back here, double check everything. We see it still shows fail. So apparently we have to do increase further about a wall thickness. In this case, so we probably need to use an extremely heavy wall. And we come back. Now it's pass. This is just an example. In the real case, we have to compare a lot of other things too. We can change the depth of cover, or Sometimes we even have a minimal depth of cover as high as a 9 foot to as the minimal. So going back, we find that if we change to 9 foot, everything's still fine. All right, that's everything about these two great API 11.2 online calculation tools. See you guys next time.